everyone, it's Miss Marsden and I'm going to take you through a lesson today on the greenhouse effect. I hope you're finding these lessons useful. So before we start, same thing as last week, turn off your phone, put it in a different room please. Don't have any other tabs open on your computer. Answer all the questions in your book, which you should have in front of you, or at least a copy of it open on the computer and a piece of paper as well. Please make sure you have 2 different coloured pens which you can be working with so you can be improving your answers as you go along. You can always rewind and listen again if you're not sure. That's why we've made these videos, so it's really straightforward for you. And obviously don't give up before the end either. So today's lesson is going to be on the greenhouse effect, but before we get started, you should have your booklet in front of you. What I would like you to do is turn to page 1, and you've got a list of do now questions. All those questions are linked to what you learnt last lesson about the changes in the environment on Earth compared to when the Earth was formed 3 billion years ago. So if you need to use your notes from last week, please do. But what I'd like you to do is complete the do now questions as a review of last lesson. And we're going to mark these on the next slide. So pause the video for as long as you need to. So, only questions that I'm really going to go through are questions 2 and question 5, because that's the stuff that people usually struggle with the most. So in terms of what locked up carbon is, it's just carbon which is no longer a gas in the environment effectively. So the 2 main ways which carbon has been locked up, which you should have covered last lesson, are it's now trapped in rocks such as limestone. And it's also trapped in fossil fuels, which are your coal, your oil, petrol, diesel, and things like that. So it's no longer a gas, it's trapped in different forms. And question 5, in terms of how that oil formed, it's dead sea creatures being trapped underground over millions and millions of years. It's a really long process, which is why it's so important when we talk about the fact that fossil fuels like petrol, diesel, and oil are going to run out really quickly. So in a different colour pen, please make sure that you've marked the answers that you got correct, so well done for that. Any that you didn't, please make sure you put it into a full sentence. So for example, for question 5, you can say oil formed by dead sea creatures being trapped underground, rotting over millions of years. So you're actively thinking about that answer by putting it into a full sentence, not just copying it down. So pause the video for as long as you need to improve your answers to the do now task. So objectives for today's lesson. We need to be able to describe what the greenhouse effect is. We need to be able to describe the trends in greenhouse gas levels and the reasons for that. We need to be able to describe the effect of increased greenhouse gases. And we also need to be able to explain uncertainties in the evidence which we have for the greenhouse effect. So, getting started. You've probably experienced when you get into a car on a hot day, when you get into that car, it does feel a lot hotter on the inside of the car compared to what it does outside. And effectively, that's why it's so dangerous to leave animals or children in there. But the reason we're talking about this is because it links directly to what we're talking about in terms of the Earth as well. So why does it get so much hotter inside the car compared to outside? It's because of the greenhouse effect, and obviously on a much smaller scale. So you have something called short wavelength infrared radiation, and that comes from the sun. So what that does is, because it's shortwave, it can get through the glass in the windows of the car, and some of that energy from that radiation from the sun, it's absorbed by surfaces in the car. So if you've got black seats, for example, they will get really, really hot. And that's because some of that shortwave infrared radiation has been absorbed by them. So if you have black seats, they will get much hotter than a lighter colour seat would, for example. The radiation, which is reflected off those surfaces, is now a longer wavelength. And what happens is, because it's a longer wavelength, it can't get out of the car. It can't get back through the glass. And because it's trapped inside the car, that causes the car to heat up, because the infrared radiation is a form of energy. So when it comes in its shortwave, it can get through the glass easy enough. When it's reflected off the surfaces, for example the seats, it's a longer wavelength. And those longer wavelengths can't get back through the glass, so it becomes trapped in the car. And because that wavelength infrared radiation is a form of energy, it heats up the car. When we think about the greenhouse effect on Earth, we just think about the example in the car, but on a much, much bigger scale. So the same effect is present on the Earth, but obviously the Earth's not surrounded by a big layer of glass. The Earth actually has a layer of gases around it, and that layer of gases is formed from carbon dioxide, methane, and water vapour. We know these collective group of gases as greenhouse gases. And usually the term greenhouse gases, you think of a negative effect, you think of global warming and climate change. But actually, these exist, these gases, the layer of them exists around the Earth at all times. So what I want you to do is, bearing in mind the example I talked about with the car earlier on, I want you to look at the diagram, and I want you to have a go on a piece of paper at describing how the layer of gases around the Earth, made from carbon dioxide, methane and water vapour, how does that cause the Earth to warm? So you've got the diagram with lots of labels on there. I want you to have a go at describing it. And if you struggle, there's a link to a YouTube video which will help you to explain that diagram as well. So I'm going to pause the video. I want you to have a go at describing the greenhouse effect on the Earth using the diagram below. Take as long as you need to. So I've got the same diagram. And to be able to describe the greenhouse effect, it's just a few steps which are always the same. So the first one, you've got shortwave infrared radiation coming from the sun. Better word than that, it's being emitted from the sun, being given out. So my shortwave solar radiation, my infrared, passes through the atmosphere and it reaches the surface of the Earth. Some energy is absorbed by the Earth, and that is what causes the Earth to warm up. We need that, it is important, because obviously if it wasn't there, it would get too cold. So some of the energy is absorbed, like we just said. Some of the infrared is reflected by the surface of the Earth, but it's no longer short wavelengths, it's now longer wavelength infrared radiation. So we've now got a longer wavelength of infrared radiation being reflected from the surface of the Earth, as you can see using the arrows. It can't pass through the layer of greenhouse gases, so it becomes trapped, as you can see. The fact it's become trapped, it then reflects back to the Earth's surface, and more of it can then be absorbed by the Earth. The more radiation that's absorbed by the surface of the Earth, the warmer it's going to be. So compare my model here to what you wrote down, and make sure you've got the keywords which I've been using. If you notice, I'm using words such as infrared. I'm using words such as short wavelength. And I'm talking about longer wavelengths being reflected from the surface of the Earth. Make sure you're using these terms reflected and absorbed to make sure you're getting the top marks. So if you put something like some infrared is bounced off the surface of the Earth, then what you can do is you can highlight it and you can improve it and say it is reflected from the surface of the Earth. Just pause it for as long as you need to improve your definitions. So using your diagram, which you've now annotated, what I would like you to do on page 2 of your booklet, it asks you to complete a written task which is talking about the greenhouse effect on Earth. So what I would like you to do, I'd like you to complete the question on page 2. I've given you some sentence starters which are in italics at the bottom if you struggle to get started. You need to make sure you've included all of the key words which are in the list. And please either underline them or highlight them to make sure that it's clearly visible that you have used each of the keywords, which are wavelength, radiation, absorbed, radiated, trapped, energy, and reflected. The only one which you might struggle to put in there, which I don't mind if you miss this one out, is radiated, because you can use reflected as well. It's kind of interchangeable. So pause it for as long as you need to. I'd recommend spending about 10 minutes on this task. We're going to mark it on the next page. So I'd like you to check your answers. So the layer of greenhouse gases around the Earth is formed of carbon dioxide, water vapour and methane. So notice how I've underlined the key terms which I need to include in my answer. So I've got short wavelength infrared radiation is emitted from the sun. When they reach the Earth, some is absorbed by the surface of the Earth and some is reflected. You need to add that extra bit of detail and say the reflective waves have longer wavelengths. So some of that reflected longer wavelength radiation escapes back into space. Some of it becomes trapped by the greenhouse layer. It's then reflected back off the greenhouse layer to the surface of the Earth, and that causes the atmosphere to warm. Any keywords which are missed, please add now using my answer as a model. So we've talked about the greenhouse effect, but now what we need to talk about is how is human activity impacting the greenhouse effect? How is it causing it to change? So you've got two diagrams. On the left, you've got the natural greenhouse effect. Like I said, greenhouse gas is your carbon dioxide, methane, and water vapour. They're always there. The greenhouse effects will happen naturally even if humans didn't exist. But on the right, you've got the human enhanced greenhouse effect. So that's talking about the impacts that humans are having on the greenhouse effect. So what I would like you to do is I would like you to compare both of the diagrams. So I'm going to pause the video. I've kind of got you started on the slide, but what I'd like you to do is to compare both diagrams to explain the difference between the natural greenhouse effect and the human enhanced greenhouse effect. So pause the video for as long as you need to, but it shouldn't take longer than 2 minutes. So as you can see, the human enhanced greenhouse effect, you've got a much thicker layer of greenhouse gases. So you've got a much more carbon dioxide being produced, which is CO2. Methane is CH4. And we've got much more water vapour, as well as much more nitrogen oxide. So there's more greenhouse gases, and that layer has become much thicker. What that means is not as much radiation is escaping through that thick layer. So you can see that the arrow where it says heat escaping into space, when the natural greenhouse effect is being taken into consideration, that arrow is much thicker. It means more energy is able to escape back into space. But when we're taking into account the effect of human activity, much less heat's getting back out into space, much more of it is re-emitted towards the Earth, and that means that the Earth is becoming warmer. So feel free to add any of that extra detail to your notes that you made. So, without a layer of greenhouse gases, like I said earlier, it's important because it's needed to maintain the Earth's temperature to be warm enough where life can exist. Without it, it'd be far too cold for a lot of plants and for a lot of animals to exist. It'd be minus temperatures. So the problem that we're talking about is not the greenhouse layer itself, it's the thickness of it due to human activity. So if we look at the graph below, 250 years ago, the percentage of carbon dioxide in the atmosphere was about 0.03% of the atmosphere. But if we compare this to modern day, it's gone up by a third, and it is now 0.04% of the atmosphere. That might not seem a lot, but it is enough to have a significant impact on the temperature of the Earth. Notice how I just described the trend on the graph using labels from the axis. So when I'm describing, remember from last week, I take specific labels. So 250 years ago from the x-axis, the percentage of carbon dioxide in the atmosphere was 0.03. And then I compare it to another set point, so compared to 0 years ago, where the temperature is now 0.04. Notice I was using specific language from each of the axes, talking about time in years and percentage of carbon dioxide in the atmosphere. So what's causing greenhouse gases levels to rise? It's pretty self-explanatory, and we have talked about this a lot lower down school. So carbon dioxide levels are rising because of deforestation. So we've got fewer trees, and trees we know carry out photosynthesis, and photosynthesis removes carbon dioxide from the atmosphere. So less trees, less carbon dioxide is being removed, and the level of carbon dioxide in the atmosphere is increasing. Also, we're burning more fossil fuels, like you can see in the diagram on the right, and that's releasing that locked up carbon that we talked about in the do now task back into the atmosphere. So when we burn oil, coal, petrol, diesel, for example, that locked up carbon gets released as carbon dioxide back into the atmosphere. So that's carbon dioxide. In terms of methane, the levels are rising because of more landfill sites, which is where we send our rubbish. And that gives off methane as those materials rot. So when you send rubbish to a landfill site, as it begins to rot, it releases methane. So more people, more rubbish, more methane. So we have more rice fields, which give off methane because of the bacteria in them. And more cows, and cows give off methane when they pass gas. So the more people there are, the more demand for beef. We have more cows, which means more methane. So from the diagram, what you can do is you can now make a list of the consequences of an increased greenhouse effect using the diagram below. So pause it for as long as you need to make a list of consequences of an increased greenhouse effect. So what I'd like you to do now is, using the information that I've gone through, is I'd like you to answer the questions on page 3 in your booklet, and we're going to mark them together on the next slide, so please give it your best shot. Please watch the video that I linked earlier if you're really struggling, and please go back and rewind the video if there's any extra information you need to go over. So pause the video for as long as you need to, and we're going to go through them together. So what I'd like you to do is use my model answer on the PowerPoint to be able to improve your answer. So the layer of greenhouse gases is getting thicker. We haven't created it, it was already there, we've just made it thicker. And that's because there's more carbon dioxide, more methane, and more water vapour. So that means more of that long wave radiation is being trapped, it's being reflected back off that thick layer of gases, and it's causing the surface of the Earth to get warmer. So carbon dioxide's rising because of deforestation and increased use of fossil fuels. And methane's rising because of increased number of rice fields, increased number of cows, and then more rubbish at landfill, which is causing increased methane when it is rotting. So be really specific there, say when is the methane being released. It's released when the rubbish is rotting. So make sure you've improved that in a different colour pen, and then we'll move on. So, key skill that you need when we're talking about any sort of climate change, greenhouse effect, is graph reading again. So, what we've got is, we've got several different axes. This is a little bit more confusing than last week, because on the left we've got the carbon dioxide concentration. So in blue we're talking about the carbon dioxide concentration. Again, we've got years along the bottom, and then we also have temperature change as well. So what we can see is that the temperature change in red fluctuates, so it goes up and down. But the carbon dioxide concentration has gone up in a smoother curve. So what we can see is that actually both the temperature change and carbon dioxide concentrations have increased. So we could probably say that carbon dioxide is causing it. However, because both lines aren't exactly the same, it's difficult to prove that carbon dioxide is causing the global temperature increase, because it fluctuates so much. We can state that they are related and that there may be a relationship, but we can't prove it. So what we need to do, we always need to look at data really closely. Like I just did, I said that it is fluctuating, and this doesn't necessarily prove that carbon dioxide is causing the Earth's temperature to rise. So there'll always be some places where the data doesn't correlate, and that means that they don't match effectively. You could say this might be because of accuracy of readings. For example, they might be measuring temperature in a different way in one place compared to what we would here. Climate change on a global scale is difficult to measure, so we can never really prove that carbon dioxide and increased greenhouse gases are causing the temperature change. But because of that relationship we can see between increased human activity and increased greenhouse gases, more scientists are now starting to agree that this is the case. Increased greenhouse gases from man-made activities are leading to climate change and an increased temperature of the Earth's surface. However, some people do disagree with it, particularly people who have oil companies. Well, effectively, they're not going to agree with it because that will go against their business model. So you always need to evaluate who would agree, who would disagree, why. So last thing for today's lesson for all of us is there's 7 questions. What I would like you to do, this is a learning check of everything we've done today. Answer the 7 questions either in the booklet or on a piece of paper, and then we will mark them together. This is to check that you have understood everything. If you feel confident, do it on your own. If you've struggled a little bit, then please feel free to go back through the video to re-listen to this information and use that to help you answer the questions. So pause the video for as long as you need to. So, answers are on the board. Please can you make sure that you have improved your answers and give yourself a mark out of 7. Number 6 is going from the graph. Like I said, the higher the concentration of carbon dioxide, which means the more carbon dioxide, the higher the global temperature. We saw that overall trend on the graph, even though the temperature over time did fluctuate. So number 7, you could just say that the temperature over time fluctuates, even though carbon dioxide levels have always increased. So at the back of your booklet, you've got some exam questions. I'd like you to firstly attempt those exam questions, and the mark schemes are in the continuity of learning folder for you to assess once you've finished. There's also a fluency test at the back of your booklet which I would like you to have a go at, and the aim of that is to improve your skills which you need to be able to access the How Science Works part of the exam. So it's just a way of keeping up your skills even though you're not in a classroom. You can find the mark scheme for the fluency test in the continuity of learning folder as well. And please don't forget to send either a picture of your work or the completed booklet to your class teacher so that they can so that they know you've done it. You also need to complete your Educate quiz by Monday at 8 AM, please. Any problems, please email your class teacher.